Now let's look at the problem of how to find the modulus and the principal value of the argument of a complex number. First, we look at the definition. The modulus is also called the absolute value of the complex number. It's essentially the length of the vector. So we have, using the Pythagorean theorem, is that radius or hypotenuse is equal to the square root of a squared plus b squared. And we can put any complex number in the so-called polar form, and that's what we have. And we can also find the principal value of the argument. That's the angle theta between negative pi and pi. So let's look at 3 examples over here and to see how we can find both the modulus and the principal value of the argument. Okay, let's look at the first one. And it's pretty a straightforward calculation for the r. So we have square root 1 squared and plus root 3 squared. So we have root 4, and that's going to be 2. Okay. So if we rewrite this complex number, then we have the following. So this one is equal to 2. We put the modulus in the front, and then since we are multiplying this expression by 2, so we balance it by dividing 2 throughout this number over here. That's what we have. And then from this expression, we recognize that r, of course, is 2, and cosine theta is 1/2, and sine theta is root 3 over 2. Pretty much we can now see what this theta should be, but sometimes we also use this formula. We say tangent theta is equal to b over a, and we have root 3. And together we see that theta must be equal to pi over 3. Okay. Now, we can see theta is equal to pi over 3 because we know cosine pi over 3 is 1/2, and sine pi over 3 is equal to root 3 over 2. And in the complex plane, we can also sketch the diagram of this number. So what we have over here, so this is 1 over here, then we have root 3, which is a point something, so it's over here. And this is what we have. So let's move over here a little bit. So we have something like this. This is 1, and this is going to be root 3. And we see that this is the number 1 plus I root 3, and the angle is pi over 3. Okay. So we have this angle over here is pi over 3. Now, let's look at the third example over here. We have -1 minus root 3 and I. Let's try to see the difference. And if we calculate the modulus, it's exactly the same. Square root -1 squared and plus -3 squared. And this will give us, again, 4, root 4, and it's equal to 2. So we have the same modulus. And also, if we just look at the tangent theta, we see something like this. Tangent theta is going to be negative root 3 over -1 is root 3 as well. But our theta over here is not going to be pi over 3. The reason is we put a note over here. Tangent theta is equal to root 3, we have two possibilities if we want theta to be inside this interval from negative pi to pi. Theta can take two values. One is pi over 3, and the other one is theta is equal to pi over 3 minus pi, which is negative 2 pi over 3. And we will see this is now actually our answer. So by tangent theta alone, we cannot tell what this theta's principal value is. We have to look at the signs of cosine theta and sine theta. Or we can say the following. That reason is that sine negative 2 pi over 3 is exactly negative root 3 over 2, and cosine negative 2 pi over 3 is equal to negative 1/2. So because we have two negative signs over here, negative 1 minus root 3, so this complex number actually is in the third quadrant. So what we have, theta must be equal to negative 2 pi over 3, and in the third quadrant. And we can see this pretty clearly if we plot it over here. So this is going to be negative 1, and here it's going to be negative root 3. And this point over here is negative 1 plus I root 3. And we see that it is on the same line as the other angle, which is pi over 3 over here. This is pi over 3. But our angle over here, this part, is negative 2 pi over 3. And that is the right answer for this problem. So we have, for this complex number, the principal value of argument theta is equal to negative 2 pi over 3. So with this in mind, let's solve the last problem over here too. And we have, at this time, we have negative 1 plus root 3i, negative 1 plus root 3i. And we will see the same thing. The modulus r is going to be equal to 2. And what is the theta over here? If we look at the angle over here, this is what we have. We have x is negative 1, and y over here, or b over here, is root 3 positive. So what we have is this angle over here. And if we look at the principal value of the argument, that's what we have. So how can we find that? So we can say tangent theta is equal to root 3 over negative 1, which is negative root 3. But we have two values. Theta can be negative pi over 3, or theta can be pi minus, theta can be negative pi over 3 plus negative pi over 3. The reason is we know tangent theta is of period pi. So we say tangent theta, if you add or subtract a pi, it's the same thing as tangent theta. That's the reason. That's why for these two thetas, you would have the same negative root 3. And the correct answer for us now is this one. So we have theta is going to be 2 pi over 3. Or simply put, this is exactly the thing we discussed in trigonometry. We have cosine 2 pi over 3. This one is negative 1 over 2. And then sine 2 pi over 3 is positive root 3 over 2. Of course, this is what we are trying to show. Negative 1 plus root 3i is exactly 2 times cosine 2 pi over 3 and plus I sine 2 pi 3. And to conclude, for the others, we have 1 plus root 3I is equal to 2, and we have cosine pi over 3 and plus I sine pi over 3. And the other one we have is -1 minus root 3I, and that's going to be 2. And we had cosine -2 pi over 3 plus I sine -2 pi over 3. And that's all we have for how to find the modulus and the principal value of the argument.